The center of the Milky Way galaxy is one of the brightest and most mysterious regions of our galaxy. Like a cosmic hearth, it glows with an intensity that belies the unseen forces at play within. So, what is in this center? Why is it so bright? What secrets does it hold about the universe we live in? In this exploration, we embark on a journey to the heart of the Milky Way, a place where the laws of physics are pushed to their limits, where stars are born and die in spectacular fashion, and where a supermassive black hole, a cosmic titan, holds court. Fasten your seatbelts and prepare to be amazed as we unveil the secrets behind the brightness at the heart of our galaxy, a place of both immense power and profound beauty. Our journey begins with a grand overview. Picture this: a vast city of stars, a swirling metropolis spanning 100,000 light-years across. That's the Milky Way, our galactic home. And just like any bustling city, it has its neighborhoods. We reside in a quiet suburb, far from the hustle and bustle of the galactic center. But if we could travel at the speed of light, it would still take us 25,000 years to reach this central hub. As we venture closer, we encounter dense clouds of gas and dust, the raw materials from which stars are born. These interstellar clouds obscure our view in visible light like a cosmic fog. But don't worry, we have ways of peering through this cosmic veil. Using telescopes that can see infrared and radio waves, we can penetrate the dust and witness the true spectacle that lies at the heart of the Milky Way. And what a spectacle it is. The galactic center is a region of intense activity, a cosmic cauldron where stars are packed together 1,000,000 times more densely than in our neighborhood. It's a place of extremes, where gravity reigns supreme. At the very core of this maelstrom lies a behemoth, an object so massive, so dense that it warps the fabric of space-time itself. A supermassive black hole. Meet Sagittarius A for short, the supermassive black hole at the center of our galaxy. You might be thinking, a black hole? Shouldn't that be black, invisible? And you'd be right. Black holes don't emit light. Their gravity is so strong that nothing, not even light, can escape. But the region around a black hole is different. As gas and dust spiral inwards, they heat up to millions of degrees. This superheated material emits an intense glow across the electromagnetic spectrum. The material falling into Sgr A creates a swirling disk of superheated gas and dust called an accretion disk, and it's this accretion disk that shines brightly, illuminating the galactic center. Astronomers have been studying Sgr A for decades, tracking the orbits of stars and its gravitational grip. These observations have allowed us to measure its mass, 4 million times the mass of our Sun, an object so massive yet compressed into a region smaller than our solar system, dictating the cosmic ballet at the heart of our galaxy. Let's take a closer look at this accretion disk, this swirling vortex of matter falling into the black hole. Imagine a cosmic whirlpool, a maelstrom of gas and dust spiraling inwards towards oblivion. As material gets closer to the black hole, its velocity increases, friction building up between particles. This friction generates heat, immense heat, heating the material to millions of degrees. At these temperatures, matter glows with an intensity that dwarfs even the brightest stars. It's this incandescent glow from the accretion disk that contributes significantly to the brightness of the galactic center. But it's not just heat we're talking about, it's energy on a scale that's hard to fathom. The material in the accretion disk emits radiation across the entire electromagnetic spectrum, from radio waves to gamma rays. Astronomers use telescopes tuned to these different wavelengths to study the properties of the accretion disk and learn more about the black hole it feeds. Think of it like peeling back the layers of an onion. Each wavelength of light reveals different details about the temperature, density, and composition of the accretion disk, providing us with crucial clues about the physics at play in this extreme environment. And it's not a static environment, not by any means. The accretion disk is a dynamic, ever-changing structure with material constantly falling inwards, swirling around and ultimately crossing the event horizon, lost forever from our view. Chapter 4, Stellar Nurseries, A Blaze of New Life. The galactic center isn't just a place of destruction, it's also a region of intense star formation. While the black hole devours matter at its heart, the surrounding regions are teeming with stellar nurseries, vast clouds of gas and dust where new stars are born. These stellar nurseries are some of the most active in the Milky Way, fueled by the abundance of raw materials concentrated in the galactic center. As gravity pulls these clouds of gas and dust together, they collapse under their own weight, igniting nuclear fusion at their cores. And when stars are born, they burst onto the scene with a blaze of glory. Massive stars, much larger and hotter than our sun, shine with an incredible intensity, bathing their surroundings in ultraviolet radiation. This intense radiation ionizes the surrounding gas, causing it to glow brightly. Imagine a cosmic fireworks display with newborn stars illuminating the surrounding nebulae, painting the galactic center with hues of red, blue, and green. These massive stars live fast and die young, ending their lives in spectacular supernova explosions, which further enrich the interstellar medium with heavy elements. So, amidst the chaos and destruction at the heart of the Milky Way, a cycle of stellar death and rebirth plays out on a grand scale, adding to the dazzling tapestry of light that emanates from the galactic center. Chapter 5. Interstellar Dust and Gas Clouds, a Cosmic Veil of Light. Now let's talk about the interstellar medium, the vast expanse of gas and dust that fills the space between stars. This might sound like empty space, but it's far from it. It's this interstellar medium that gives the Milky Way its distinctive spiral arms and plays a crucial role in the life cycle of stars. In the galactic center, the interstellar medium is particularly dense and turbulent. It's filled with all sorts of exotic particles, molecules, and dust grains, remnants of past supernova explosions and stellar winds. And these particles and dust grains don't just sit there passively, they interact with light, scattering and absorbing it. This scattering and absorption of light by interstellar dust and gas clouds contribute to the overall brightness of the galactic center. In fact, if we could magically remove all the dust and gas from our galaxy, the Milky Way would appear much dimmer and less impressive. Think of it like fog on a city night. The fog itself might obscure our view, but it also scatters the city lights, creating a diffuse glow that illuminates the surrounding area. Similarly, interstellar dust and gas clouds scatter and absorb light from stars in the galactic center, creating a diffuse glow that adds to its overall brightness. Chapter 6. Dense Star Clusters and Energy Emissions, a Cosmic Metropolis. The galactic center is a crowded place, a cosmic metropolis teeming with stars, gas clouds, and of course the supermassive black hole at its heart. But amidst this cosmic hustle and bustle, there are pockets of even greater density, dense star clusters where gravity has drawn stars together in a tight gravitational embrace. These star clusters are some of the oldest and most massive in the Milky Way, containing hundreds of thousands of stars packed into a relatively small volume. And where you have a lot of stars, you have a lot of stellar activity. Stars are constantly emitting energy, from the gentle glow of red dwarfs to the intense radiation of massive stars. And then there are the supernovae, those cataclysmic explosions that mark the end of a star's life. These events release tremendous amounts of energy, briefly outshining entire galaxies. All of this stellar activity, the constant hum of starlight, the occasional burst of a supernova, contributes to the overall brightness of the galactic center. It's like being in Times Square at night, surrounded by a dazzling array of lights, each one representing a star or a stellar event. And just like in a bustling city, there's always something happening in the galactic center, some new stellar drama unfolding, adding to the ever-changing tapestry of light that emanates from this cosmic metropolis. Chapter 7. The Future of the Galactic Center. A story still unfolding. As we conclude our journey to the heart of the Milky Way, we're left with a sense of awe and wonder at this cosmic region. The galactic center is a dynamic, ever-evolving environment. The supermassive black hole at its heart continues to draw in matter. New stars are born while others end in supernova explosions. Astronomers use powerful telescopes to probe its secrets. They seek clues about the black hole's growth and interactions. Will it play a role in the Milky Way's fate, billions of years in the future? It's a journey far from over, a story still unfolding before our eyes. The brightness at the heart of the Milky Way is a testament to the immense power of the black hole, the birth of new stars, and the ceaseless energy of a galaxy in constant motion. It's a reminder that we live in a vast and dynamic universe, filled with wonders that we are only beginning to comprehend. This bright center, shrouded in mystery and brimming with activity, continues to shine deep in the universe, a beacon that draws our curiosity ever inward. As we continue to explore the cosmos, The heart of the Milky Way stands as a reminder of the boundless mysteries that still await us. And each new discovery, each piece of the puzzle we uncover, brings us one step closer to unraveling the secrets of the universe and our place within its grand design.